GMAT all day.
So far, we have been talking about our 2D quadrilaterals, our flat quadrilaterals. Occasionally on the GMAT, though, they ask you about 3D quadrilaterals, also known as cubes. And there are two types of cubes that you can be asked about. There are regular cubes, and these are the most common. Then, less commonly, they'll also ask you about what they sometimes call rectangular cubes. We will talk about both of these here. Now, just like with cylinders, the two things that they most commonly ask about regarding cubes are volume and surface area. So we will talk about how to find those two things for both of these types of cubes. So what is a regular cube? A regular cube is just a cube where all the sides are the same. In other words, if you think of a cube, any type of cube as having sort of 6 panels, a bottom and a top, a left and a right, and then a front and a back. A regular cube is going to be made up of 6 squares. And so for a regular cube, you can think of this as meaning your length, your width, and your depth are all the same. And so for any type of cube, your volume is just going to be your length times your width times your depth, or sometimes they just say x times y times z. Now for a regular cube, that means because your length, your width, and your depth are all the same, your volume is just going to be side cubed. What about your surface area? So if you think back to our video on cylinders, the surface area for a 3D shape is just the area of all the components of that shape if you were to flatten them out into their 2D components. And so we said before, with a regular cube, you can think of it as being made up of just 6 squares. So each of those squares has a area of s squared. And so therefore, since you have 6 of them, the surface area for a regular cube should just be the sum of those 6 squares area, or 6s squared. Now, what is a rectangular cube? So a rectangular cube is a cube where all of your sides aren't necessarily the same. And so that would look, instead of being composed of a bunch of squares, like it's composed of rectangles. So it would look something like this, like a matchbox or something. So in this case, your volume, and so we call this x, this y, and this z. But here your volume is truly going to be just your length times your width times your depth. Now, what about surface area? Because here is where sometimes people can make silly mistakes if they don't think about it. So what would the surface area be? Because now, unlike with your regular cube, where all of your squares were the same, here all of your rectangles are not necessarily the same. They don't have the same length, width, and height. So you got to actually separate out your 6 individual rectangles and find their individual areas. And so for this front rectangle here, what is the area going to be? So that's just going to be x times y, right? And so your front and your back are going to match. And so between those two rectangles, we have 2xy. So, and then we got our 2 side panels. Those are going to be equal to each other. And so the area of each of those is just going to be y times z. And so because we have 2 of them, that's 2 yz. These are your right and left. Plus, and then there's your top and your bottom rectangles, which are each just x z. And so together it's just plus 2x z. This is pretty much everything you need to know about cubes for the GMAT. So let's do a problem testing these ideas. The length of a perfect cube, and so perfect in a regular cube, same thing, with a volume of 64 cubic centimeters, is extended by 2 centimeters. What is the percent increase in the cube's surface area? So even before we start talking about cubes or surface area, we got to think back to how do we calculate percent increase? And so that's just new minus old over old, or in this case, it would be the new surface area after the extension minus the old surface area all over the old surface area. So I need to find these two things. So to start, we have a perfect cube we know its volume is 64 cubic centimeters. So side cubed is equal to 64. That means you have to take the third root of 64 to get just an individual side. And I believe 4 times 4 times 4 is equal to 64. That's worth knowing. Each individual side here is just 4 centimeters. So from this, we should be able to get the old surface area. So the old surface area, each of our squares has an area of 16, 4 times 4. Since we have 6 of them, our surface area should be 96 square centimeters. So we can plug that in, and without doing much work, we got 2/3 of our fraction filled out. So now we just got to get the new surface area. It says the length is extended by 2 centimeters. So it might be a little bit confusing what that means, because our lengths are all the same from where we're starting, because all our sides are the same. So what they're saying is just really in any direction, you can increase it, but only in one direction. And so most commonly, I would say, way to imagine it is horizontally. So if they extended this to 6 centimeters, what would that look like now? If you did that, your cube is being extended in only one dimension. Everything else is staying the same. And so this length here would be 6 now, and this here would be 6 now, but your width is 4, and your depth here is also still 4. These did not change. And so we would calculate our new surface area. So we got our front and our back are each 6 times 4, so that's 24. So 2 times 24 is 48. So front, back. And then we got our 2 side rectangles. So each of these has a area of 4 times 4, or 16. So we got 2 of those. So it should be 32. This is left, right. And then we got our bottom and our top rectangles. And again, these each have an area of 24. So this would be another 48. This is the top and bottom. So our new surface area should have an area of 48 plus 32. What is that? I'm sorry, 96 plus 32. I knew this didn't seem right. $128. And that should be enough to solve for our percent increase. So 128 minus 96 all over 96. This is 32 over 96, which is 1/3, also known as a 33.3% increase. So D is the answer, and that is it for cubes, and that is it for quadrilaterals in general. We will just do one more video filling out our cheat sheet. So see you in the next video.